Hey guys, all right, so this is example 3. The last video we talked about you guys trying out the U-try. Did you guys come up with the tangent is y if I write it as y equals mx plus b, if y equals 3 over 4x minus 25 over 4, and the normal is y equals negative 4/3 x. Of course, I will always accept the answer in point-swift form. So don't worry about if you put it in point-swift form, as long as it is equivalent to those answers, okay? So today we are going to talk about example 3, or at least on this video. Whether it is assigned the same day or not, that is to be determined. Use the implicit differentiation to find dy over dx, and then also the second derivative. So I'm going to need a lot of space, so I'm going to write, okay, so I'm going to write this question again over here. X to the 2/3 plus y to the 2/3 equals 1. So I'm going to do the derivative, the first derivative. So the power rule says I'm going to drop down the power times x, subtract 1, so negative 1/3. Minus 2/3, why am I saying minus? Drop down the power, positive 2/3, I'm sorry, times y to the negative 1/3, that's what my brain's saying. Now, because I am doing the derivative with respect to x, I need to multiply by y prime, or dy over dx. The derivative of 1 is always 0. Our goal is obviously solve for dy dx because it says to find dy dx. So the first thing is I'm going to move, subtract this right here to the other side. So if I subtract that, I keep 2/3 y to the negative 1/3 dy dx equals negative 2/3 times x to the power of negative 1/3. I will get rid of the fractions first, so multiply both sides by its reciprocal, 3 over 2. If we multiply by its reciprocal, I now have y to the negative 1/3 dy dx equals, if I do that, cancel, 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 cancel. So negative x to the negative 1/3. Now divide both sides by y to the negative 1/3, okay? So our dy over dx is, I can keep this as, no, remember, I don't want your answer to ever be a negative exponent unless you can't help it. So they're both negative exponents, so I'm going to rewrite it so that way it's a positive exponent. So I can move the y to the numerator and move the x to the denominator to make all the exponents positive. If you like radical better, by all means, you can write it like this, okay? You can write cube root of y, negative cube root of x, negative cube root of y divided by positive cube root of x. So that's the first derivative. Next, we are going to try to do the second derivative, which again, I still need lots and lots and lots of space, okay? So the second derivative is, I'm going to take, obviously, the first derivative and do sort of a quotient rule. So I'm going to let u be the numerator, which is negative y to the positive 1/3 power. So u prime would mean negative 1/3 times y to the negative 2/3 times dy over dx, or y prime. V, I'm going to let it be the denominator, which is x to the 1/3. That means v prime is 1/3 times x to the negative 2/3. Since it is with respect to x, I do not need to write x prime, okay? Now I'm going to rewrite the quotient rule. Oops. I'm trying to do second derivative. d square y over dx squared. So the rule says u prime times v minus v prime times u all over v squared. I did all the background work already. Now I just have to plug in what u prime v prime u are, okay? So u prime is this whole thing right here, negative 1/3. I'm going to write a lot of steps out, dy dx. So that's u prime times v, and v is not as ugly, it's just x to the 1/3, no big deal, minus v prime, which is 1/3 x to the negative 2/3 times u, which just happened to be a negative y to the 1/3, okay, all over v squared, and v is x to the 1/3 to the square. Okay, now this is the step where I have to like really take my time and double check my work. Okay, so this right here and this right here, I'm going to put them together to the front. And normally when I write stuff, I like to write x in front of y, so that's why I'm just moving it in front of the negative y to the negative 3/3. And then multiply by dy over dx minus, now this is a part where two negatives will change it to a positive. So that's going to be positive 1/3 maintains in the front. I like to write x first, then y to the positive 1/3. All over on the bottom, power to the power, I'm just going to multiply them. That's really x to the 2/3. Okay. So I will, technically, I can even divide all of that right there, x to the 2/3. Okay, let's go see how far we can go. So from here, do you want to simplify first and then plug in dy dx, or do you want to plug in dy dx and simplify? That's really a personal choice. Well, since I already, looks like I highlighted already, why don't I just plug it in first? Oops. Why don't we go and find dy dx? And where the heck is dy dx? Orange. dy dx is back to over here. dy dx. I'm going to plug that in. Okay. So pinch it in so I can see what the whole dy dx is. Negative 1/3 x to the 1/3 y to the negative 2/3 dy dx. Here we go. Negative y to the 1/3 all over x to the 1/3. That's dy dx. I'm just writing that all in. Okay. Then I'm going to copy everything else over as is. Positive 1/3 x to the negative 2/3 y to the 1/3 all over x to the 2/3. Now, as you can see, I can get rid of those. Those two guys would be canceled. So now, next step, 1/3 negative. Those x's are already gone. So, but actually, this negative and that negative is now going to be a positive. I'm working this out as I'm writing. So, okay, so positive 1/3. Now, y to the negative 2/3 times y to the positive 2/3. The y's are the same, so I'm going to add the exponents, okay? When I add the exponents, negative 2/3 and a positive 1/3 is now a negative 1/3. So that's all I have left on that piece. Then I'm just going to copy everything else. Oh, ignore this thing right here. This thing belongs to that top. So then I'm just going to copy everything over, and we will now simplify the denominator. How about if we were to do this? Okay, would you be okay if I divide, if I divide each side like this, x to the 2/3, x to the 2/3, okay? Then, if it's a negative exponent, I will bring it to the bottom. Just like that guy has a negative exponent, just that guy. So here's the next step. 1/3, x to the 2/3. I'm going to bring y to the bottom to make it positive, plus 1/, the 3's on the bottom, x to the 2/3 on the bottom, bring out the other negative to the 2/3, and then y to the 1/3 on the top. So that's what I now have. Okay. If I brought this on the bottom, can you make this a positive right here? Now I will try to simplify as much as I can. Okay. Let's continue with the basic algebra here. On the top, I have 1/. On the bottom, I have 3x to the 2/3, y to the 1/3. Then on the top over here, I have y to the 1/3. On the bottom, I will add those powers. That's really 3x to the 4/3, just like that. Then looks like I might need to find, let's see. I need to find a common denominator. Are you okay with that? Okay. So what would happen if I find a common denominator? This side right here has x to the 2/3 already, so I don't need to multiply, but I'm going to multiply this side by y to the 1/3 and this side by x to the 2/3. What I multiply to the bottom, I multiply to the top. Okay, there you go. So now, next step, are you ready? Common denominator. So 3 is already there. X to the 4/3, y to the 1/3. Okay, that's on the bottom. On the top, I have x to the 2/3 plus these two. The bases are both y, so I mean I can add the exponents. So that really becomes y to the 2/3. Well, y to the 2/3, can't really stop right there now, could I? Y to the 2/3 really become, this is the part where it's super important. Whoop, 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 whoop. That right there, and whoop, 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 right there. I have to use substitution and plug it back in. So this is 1 over, because x to the 2/3 plus y to the 2/3 is 1. So I have to take that out and put it 1, because that's even simpler. 3x to the 4/3, y to the 1/3, and I think that's as far or as simple as I can go. That is the second derivative. So the takeaway is this, guys. The takeaway is, I'm going to use a different color, okay, to highlight. Pay attention to where dy dx was. Use that to substitute with the original. Then, once you get to the final answer, double check to see if I can use the original question to substitute again. So those are the two locations that you need to be very careful about. And this is the end of example 3.